Okay, so this is a run-through of a little Space Invaders game in Rebol. Demonstrate how to do a game loop using the GUI instead of draw. This game starts out with some definitions. We have a function called E, which will run when the game ends, and it takes one parameter, which is going to be some text that will alert to the user before the game closes. That Q closes the game, ends the game. So next we have a little block labeled S, which is where all the positions of the invaders graphics are going to be placed. The way this whole layout works is we're going to create basically 600 boxes, and we're not going to draw anything using the draw commands. We're just going to change the images on those 600 boxes. So we have like 600 panels that we can draw things on, and they're all numbered 1 to 600, and so these are the initial numbers of the boxes we're going to be drawing those images on. And next we have a P variable, which is the speed, initial speeds. That's how long is weighted between each event loop. And then we have an M variable, which is the position of the missile that we're shooting at the invaders. And then we have an L variable, which is the position where the player is. And then we have a D variable, which is the direction that the player is moving. And then we have a G variable, a G word. This G contains the initial GUI layout. So you can see in this block here, starting with G, all we're doing initially is placing some key handlers. So we have key handlers for the A, S, and space keys, and when those keys are pressed, this is what happens. If the has some bounds checking for where the player is. Basically, if the player is at a space greater than 571, then it'll do this little bit of code. And this rejoining code, what it's doing is we're labeling, when we create the screen, we're labeling these boxes B1 through B600. So this is a really quick way just to kind of get the label the box that we want to change. And so when we press on the A key, we're changing whatever key, or I'm sorry, whatever box, that L variable, whatever box number the player is currently on, and we're changing that image to nothing. And then we're updating the position of the box, in this case by -1, and in the case of the S key by +1. And it has some bounds checking to make sure. So those little greater than and less than conditions check to make sure that the player stays just on the bottom line of the screen, and erases the current position. And then the L position will be handled later in the game loop. So we're updating his position, and it's redrawn down here in the game loop down below. The space key shoots the missile, and what happens here, again, we have some bounds checking. Make sure that the missile is at a position less than 1, so it's above the top of the screen, or off the top of the screen, and that ensures that you can only shoot one missile at a time. Make the gameplay a little bit tougher. And then if that's the case, as long as there's not a missile currently on the screen, then it sets the current position of the missile to where the player is. And then later on during the game loop, that missile position is moved up one box at a time on the screen, one line at a time on the screen. So now here's where the rest of the GUI is created. We have a repeat loop. We're going to do this 600 times. I variable is the counter variable for that loop, and we're appending. This append word is just the exact same thing as append and reduce. So we're reducing this block and then appending that reduced block to the GUI block. And this is where we create the variables. So if you the variables for the or the labels for the boxes. So you can see we're using a two-set word. That's basically going to put a colon at the end of the word. And so we're creating boxes with the letter B, labeled letter B, and the number 1 through 600. So you're creating 600 of these boxes. Each of these is a box 20 by 20 pixels across. And as we go through this loop, there's a check here to see this little modulus checks the remainder of a division function. So if we divide the current counter 1 through 600 by 30, and if that remainder is 0, we append a return to the GUI layout. So basically, every 30 boxes, we're starting a new line. That's what that little line does here. So when this is done, we're going to have all these things that were in the GUI above, the key definitions, and then we're also going to have 600 boxes labeled B1 through B600 with a return every 30 characters. So we're going to get 20 lines of 30 boxes on the screen. And we use those boxes as the position to draw everything. Then we lay out the GUI, so we're laying out this G block that we created, and we're using view new with the new refinement. What the new refinement does is it puts the layout on screen and actually views it, which we're labeling W, so we can refer to that later. But with the new refinement, there's no event loop. So typically you use view new when you want to create a layout and then make changes to the layout sort of dynamically before doing the events. There's a do events function in Rebol that'll start the event loop. But we're not even going to use that. We're going to use our own little event loop, which we're creating with a forever loop here. So the rest of this program is the event loop, which in this case is the game loop. It's what happens every single time, every fraction of a second, to update and to check all of the conditions in the game and to do all the drawing and so forth. So that little forever loop just continuously updates this this window we've created called W, and gives us a chance to set how often that happens, and it gives a chance to respond to all of the events that have happened in the GUI and handle them manually instead of relying on an event loop, the built-in event loop. So the first thing we're going to do is basically we need to check to see if the missile is hitting the invaders block. If it's hitting anything in the invaders block, and if the missile does hit the invaders block, we need to remove the graphic that's been hit. So it's a very easy thing to do. All these things exist on numbered boxes, so we can just look at the S block, which is where all the invaders are, and we can look at the M variable, which is where the missile is, and remove at that position where a collision is found. So this little thing finds any place in the invaders block where the missile location it occurs, and then we remove that item. And then at that point we need to also remove the item from the screen. We need to remove the invader from the screen. So we use an attempt block here to handle any errors, and again we're going to do as we will for the rest of these lines, a little metaprogramming thing. Again, use one of these rejoins to build the code very easily. So we're doing this block of rejoined code. So it looks a little hairy, but it's not bad. We're rejoining the letter B with the current position of the missile, which is the M variable. So what we're seeing here in code is going to be something like B351 /image. So the image of whatever whatever box the missile is currently on, and we're setting that to nothing. So that is going to erase the image of whatever invader has been hit by the missile. And then we do another little conditional thing here, and if the invader block is then empty, then we run that E function with the word win. So we're running this function up here. The X value is now X value is now win, and so it's alerting the user with the word win and then quitting. Okay, so that checks every time we go through this event loop to make sure that the invaders aren't completely gone. So at this point, we've removed any collided invaders. Any place where an invader has collided with the missile, we've removed the invader from the screen and from the invader block. And now we're going to go through, and we're using the repeat function to do this with an I as a counter for the length of the invader block. And we're doing another what do you call rejoin. We're going to do the rejoin code. That's the concatenated code that we're putting inside this block. And so again, you can see we're looking for a character, a invader graphic, a location of a greater invader graphic, and we're using the current counter. So as we count through all these, as we step through all of these items in the invader block, it's doing this to each of the items. And what we're basically doing here is going through each of those items, and again, we're removing it, we're setting it to nothing. Those two curly brackets are the same as empty or none. So we're setting that image to none, erasing the current invader block, all the images that are currently on screen. And these two lines, they're about, you can see in my title here of this file that there are a huge number of iterations of this little game. And for this iteration, I chose to use these couple extra lines. We don't need these two lines. These two lines do some bounds checking. They check to see if the snake is reached the side of the screen, and then it kind of bounces the invaders back and forth, the invaders block back and forth. So we're creating a new little variable here called old D, and we set it to where to set it to what the old direction was. So we're using the number 1 to be the same as true. Yes and no and true and false can all be represented in different ways. In this case, we're saving that original value, which was 1, the same as true, and then we're going through again everything in the snake block, and we're checking to see again if the modulus of any of those numbers, if we divide any of those numbers by 30, if the remainder comes out to 0, then we're switching that direction to no. And then if we get a modulus of 1 for that same evaluation, then we're switching it back to yes. And then on the next line, we check to see if the old D variable is not the same as the D variable. So basically, if by going through every single one of those S things, if the invaders block, so if any of the invaders block is touching the side of the screen, then we change the direction. If old D is not the same as D, that means the direction has been changed. It's switched from no to yes or yes to no. And if that's the case, then we go through, we now have to delete each of the not delete, but move the position of every single one of those graphics down the screen. So we're adding 30 to the position. So each line has 30 boxes. So by adding 30, we're moving the whole snake block, or the whole invaders block, down to the next line. And here I just kind of snuck in, we're also at this point in the forever loop, in the event loop, we're adjusting the speed, and we're subtracting a little fraction of a second from the p-value, which is the speed value. Later on we're going to weight that value at the end of the event loop. So through each iteration of this event loop, go a little bit faster. Okay, so again we have another repeat loop, and in this case, depending upon the value of d, we're either going to add one or subtract one from the current position of each item in the invaders loop. So you have to imagine the way this works. If we have 600 boxes, each numbered 1 through 600, going across the screen, the first line is number 1 through 30, the next line is numbers 31 through 60, and so on until we get down to 600. Each position, left to right, is an incremental change. So going from 1 to 2 makes you move across the screen. Going from 2 to 3 makes you move left to right. If you move right to left, you'd be subtracting 1 from each of those positions. To go to the next line, you have to add 30 to each position, because position 1 is the top leftmost position on the screen. Position 31 is the first column in the second line, and 61 would be the third row, and so on. So as you add 30 to positions, you're going down one, and in the same way, if you subtract 30, you're going up a line in the screen. So what we're doing here is we're either moving every single, remember we're repeating over the entire length of that S block and calling that each iteration I. So here we're again either moving every single item over one to the left or to the right, or over to the right or to the left, depending on what that D variable is, whether we're going right or left. And then we do another one of these rejoined bits of code. So again, we're changing the position, or not the position, the image. We're actually drawing the image on this line, and we're using the built-in stop GIF image, just one of the image stock images that's built into Rebol. And we have this whole thing wrapped in an error check, because if we get off of the screen, so if we've drawn an image to some position that's not on the screen, so say position 601, we're going to get an error because there is no box 601. So that's going to give us an error. That means that the invaders have gotten all the way to the bottom of the screen, and gotten to the end of the playing field, and so we need to run that E function and let the user know that they've lost the game at that point. And then we have one more final, actually not just one more, two more final things we need to do here. This line, again wrapped in attempt, draws or erases and then redraws the missile. So at the current position where the missile is, it's going to erase the current missile, so that variable m, which we set up here originally to 0, it's going to put again nothing text. We're adding some text to that block. It's going to put no text on that box, and we're wrapping this in an attempt loop because, for example, if where we have that missile set, the position set initially, if that is not on the screen, there is no box 0. That'll create an error, and so it just won't do this stuff for any condition where there's an error. So that neatly handles not drawing the missile in a place where it shouldn't be. And then so after where the current position is, so say this missile is somewhere in the middle of the screen at like box 350. First, it's going to put nothing on the text of the currently existing missile, or wherever that is, and then it's going to subtract the missile position, so basically move the missile up a line. And then, in that current position, we're going to put a little bit of text on that box. That's going to be that little pipe symbol, little vertical line. So in the next iteration of this loop, again, wherever that current box is where the missile is drawn, it's going to erase it. It's going to move the missile position up 30, up another line, and then it's going to redraw it. And it's going to keep doing that along with all these other things in the event loop every single time the event loop runs. And if it moves up to a position, for example, to minus 30 or somewhere not on the screen, nothing will happen here. It'll basically just it'll first erase where it was, and then when it'll erase that pipe on the current place it was, and then when it tries to put it into position where it can't be drawn, it'll error out and nothing will happen. The attempt block will just keep the game going. And so now we're at the final line, and what we're doing is redrawing the player. So the L variable over here is going to, again, we're using a rejoin to just create this code really quickly so that we can change that box's image to, again, a built-in info.gif graphic. And so that just, if we've moved the character, or if we haven't moved it, we're changing the image to wherever the player currently is, whichever box the player is currently on. So we adjust that here by using the keys. If that value changes at all, we're just drawing that info.gif onto the current box labeled by the letter L. And then here we do the showing, the updating of the screen. So we show the W, and we handle if the user has closed the screen. So if the screen is no longer viewed, if the user has clicked on the little X in the top corner and closed the program, then we quit the program. And then at the very end of the event loop, we wait the p-value. So remember, that changes. It starts out with a very slow value, and then it changes up here, subtracting 2/10,000ths of a second every time through the loop. So this loop is going quickly, and by the time we get down to the bottom, it moves really quickly. Let's run this. Looks like I accidentally ran a version here. Let's close this one off. And so we get the Invaders block moving. If I press the fire key, or if I press the A key, you can see it moves left to right. We're screen recording, so the gameplay is a little bit slow on this tablet I'm on. The processing power is largely used by the screen recorder, so controls are a little sluggish, but you can set the speed also for the game to be as fast or as slow as you want. This will update as quickly as possible. Let's see here. So you can see I'm gonna lose that game. That basically demonstrates a full game loop, and how to handle moving several different things on the screen. So you have a full block of invaders that are being moved, and that movement is bounded. If we took this out, we could get rid of that bounding, and the invaders would basically just scroll from right to left across the screen, take out that D variable, and just increment this S variable. I'll put a couple different versions of this up on the examples.txt at rebol.com, at re-bol.com. There's an examples.txt there, which is linked at Rebel Forum. And I'll put a couple other versions of this. This current version is, well, it's 19 lines total, but the last line here is just a commented list of variables, and the first line is just a header with, again, some comments about which keys for the user work. So it's really about 17 lines of code. The shortest version I have of this is 12 lines, and so it doesn't have that right-left bounding, and it's the code is a little bit more densely packed onto each line. But you can get the basic game loop and all the functionality you need to control the player movement and the missile movement and all the bounds checking to end the game, and to control where the missiles are, and to do the collisions and the removal of each invader graphic and so on. Basically everything that's needed to make the whole game loop run with all these different objects moving around in about 12 lines, using this technique of putting boxes on the screen and changing the images or the text that's on those boxes, and using keys to control player movement and other graphics movement like the missile. So hopefully that gives you a little insight about how to do this sort of thing, these sorts of games really easily. It's great to create little puzzle games or little simple graphic games like this in Rebol with just a few lines of code. It doesn't take very long, and you can customize this. If you haven't seen the snake video, it uses the same technique, the same sort of box drawing technique and layout in Rebol's vid GUI, the default GUI in Rebol. And I should give you another example to help understand how to work with blocks of graphics on the screen, or blocks of things on the screen that need to change. Hopefully that helps.